For our project, we wanted to investigate the energy impact of your typical household pilot light. So for starters, let's look at the average natural gas flow rate through a typical pilot light. And because gas is measured in terms of volume, we'll only need one conversion factor to represent this value in terms of energy. And so doing a little research online, we found from a professor at UC San Diego investigating his own household pilot lights that he found it to be roughly about 0.44 cubic feet per hour flow rate of natural gas through a pilot light. And so if we want to convert this number into something that means, or something that we would typically see on our monthly gas bill, this comes out to about 3.3 therms per month. And assuming we are charged about $1 a therm, this yields $3.30 a month for one pilot light that is run continuously 24 hours a day, every day of the month.
So next, let's look at some estimates for the number of pilot lights in the U.S. So for this, I grabbed data from a bunch of different sources and made some best effort guesses as to the number of gas versions of those appliances that are out there in the U.S. And using the numbers you can see here, I came to about 150 million pilot lights total in the U.S. And if you divide that over the number of households, it's about 1.12 pilot lights per household. And going back and using the 0.44 cubic feet per hour usage rate estimate that we got from that article, that comes out to about 576,000 million cubic feet.
Now, if we want to see what the trend or the use of continuous pilot lights, that is those that run even when you're not using them, is in the U.S., we can look at a study published in 2005 by Cornell's Environmental Health and Safety Program that essentially said that 20% of natural gas delivered to residential consumers was wasted in non-productive pilot light operation. And if we go to the AIA website and look at the 2005 figure for delivered natural gas, we can see that it's about 4.8 million. In 2014, it was 5 million. Now, currently, in 2014, 15-ish, we can estimate that the advent of high voltage arc technology and electric appliances has decreased our wastage by some amount, let's say 1/4. And if we assume this, our calculations come out to about a negative 2.2% reduction in pilot light waste over this nearly 10-year span. Well, that's negative 2.2 reduction per year. So essentially, currently, we have a 0.76 million cubic feet wastage. Reduction rates could be faster, but according to Centerpoint Energy, gas appliances are still cheaper than electric appliances, so pilot lights remain.
So I want to talk about probably the best alternative to pilot lights would be high voltage arcs. So high voltage arcs are common in natural gas burners that don't use pilot lights, and because they operate at one instance instead of a continuous time like pilot lights, it can be inferred that they consume a lot less energy. So doing the analysis, I took numbers from various sources, plugged them all in, and the most valuable numbers are highlighted in yellow. So 2.2 joules, 6.1 times 10 to the negative 7 kilowatt hours, the kilograms of carbon dioxide. But what struck me as the most interesting was that it would take about 110,000 arcs to produce 1 cent worth of energy. And this is probably more than the entire lifetime of an appliance. So looking back at the number of about $3.30 per month to maintain a pilot light, this is way less energy, way less. And it can be inferred that high voltage arcs are extremely minimal energy, carbon dioxide, and money.
So if we're comparing some of the values that we calculated, we see that Joe's values in the second slide and my value for the wastage that we currently use is about the same. And overall, the point of this production is basically that natural gas pilot lights burn a lot of fuel and waste a lot of energy. And we should try to switch to high voltage arc technology as soon as possible.